Rails come in a number of different shapes and sizes. If I came to you and said we were going to be renewing some rail and we needed some flat bottom SEN 56 rails ordering, would you be confused? Or would your next question be to ask what grade the rails should be? Well, after watching this video, you won't be confused. In this video, we will cover the different rail types, profiles and grades. So let's take the first part of the statement, flat bottom. This is the rail type. When we talk about rail type, we are referring to the overall class in which the rail sits. The rail type might be for a specific location, or in the case of running rails, a new type may have been developed to improve the overall design and function of the rail. There are a number of different types. So let's have a look at those plain line rail types to start with. The most common in current usage is flat bottom rail. This is distinctive by its large foot and, flat bottom. The next most common is bullhead rail, which predates flat bottom rail. Bullhead lacks the large flat surface area on the bottom of the rail, so requires a very different base plate to counter the rotational forces. Once the main rail type used in a number of railways, including the UK, it is now being phased out in favour of flat bottom type rails. Other types of rails for running lines that you may come across are grooved rails for trams and metro systems. The groove is there to maintain the flangeway. We can come across other rail types that are designed for a specific function, which necessitates their shape. Switch rails, for example, are designed to pick up and transfer a train wheel, so increase in size along their length to manage this transfer gently. Check or guard rails are used to ensure train wheels stay on the rail by restraining lateral movement of the flange. They are installed parallel to the running rail on the inside of tight curves, or opposite crossings within S&C to avoid damage to the crossing nose. Conductor rails, which provide electrical power to the trains in some areas, have a wide flat head to allow for a good contact with the shoe gear of the train. This ensures the required amount of electricity passes between the two, powering the train. So, on to the next part of the statement, SEN 56. This is the profile. Within a rail type, there will be a variation of designs. As with running rails, this can stem from improvement in the designs over time, reactions to issues with previous designs, or regional preferences around the world. Profiles are commonly named with reference to the weight of a set length. Where metric is used, it will be kilograms per metre, whereas for imperial, it will be pounds per yard. The other part of the name is linked to where the design comes from. SEN, as in our example, is a European rail profile. UIC is another, which stems from the International Union of Railways. The variation from profile to profile within a rail type is in dimensions, often small, such as the rail height or the web thickness. We can see this by comparing SEN 56 rail on the left to SEN 60 rail on the right. Both are European rail profiles, weighing in at 56 and 60 kilos per metre, respectively. You might not be able to see the dimensions, but the SEN 60 rail is just over 13 millimetres taller and 2 millimetres wider at the head, but has a 3.5 millimetre thinner web. Some of the common rail profiles for running rails are shown now, mostly UK and European sizes. Most of the profiles will be known exclusively by either their imperial or metric names, but for some, they are used interchangeably, such as SEN 56, which is also referred to as £113 by some in the UK. If you know about the common American rail types, I'd be interested to know, so please do drop it in the comments. Switches and crossings are available in all common rail profiles, so that they can be easily joined to the plain line. Lastly, we come to the grade of the rail, the question you likely didn't know how to answer. Rail grade refers to the hardness of the rail. Rail grades are expressed as a number, and this number is the hardness of the steel on the Brinell scale. The Brinell hardness test uses a 10mm indenter with a large load behind it to see how much the material deforms. The result gives a number on the scale that corresponds to the hardness of the material. Hardness is a resistance of the material to being deformed. Resistance to deformation is important for a rail, as it needs to be able to withstand the passage of another steel surface, a train wheel, passing over it many thousands of times. In many countries, 260 is the standard grade used in mainline tracks, but there will be areas of track such as tight radius curves, areas of high cant, or where there is a large mix of train types and speeds, for example, where standard grade rail might wear very quickly. This wear can lead to side wear or rolling contact fatigue, both of which would require the rail to be changed. In these areas, a higher grade rail might be looked at for installation to prolong the rail life, reduce the risk of rail defects, and decrease maintenance intervention requirements. There are two main ways to increase the rail hardness, therefore its resistance to wear. First is alloying. This is adding elements to the steel, such as chromium, when making the raw steel before forming it into rails. When this is done, the letters from the periodic table for the added element are then put at the end of the rail grade. So 370 CR rail has a hardness of 370 with chromium added. The other way to increase the hardness is to heat treat the rail. This involves taking a formed rail, reheating and then cooling it again, both at tightly controlled rates. This process changes the microstructure of the steel. When a rail has been heat treated, the suffix HT is added. Often rails with additional elements will also be heat treated. So if these higher grade rails are so much better, why not use them everywhere, I hear you say? Well, the additional work required to manufacture these rails increases their price. For the majority of areas, the additional cost outweighs the benefit, so infrastructure owners tend to utilise these rails where they'll have the most benefit. So let's put it all together. We have a flat bottom type rail in SEN 56 profile. The rail is to be used on a tight radius curve traversed by slow moving freight trains that have a history of side wear. So a 350 HT rail grade would be a good choice here. A word of caution. As with all things on the railway, it may well be that you will come across different names used for the different profiles and types. Cross-section springs to mind as another way of describing a profile. However, if you understand the fundamentals of different rail types, grades and profiles, you'll be fine. Thank you for watching this video, and I really hope you have found it useful. Please do drop a comment below with any questions or queries, hit that thumbs up like button, and subscribe to ensure you don't miss the next video. Thank you.